Alright, so our last thing that we got a bit cut off before doing is, I guess, linking the two graphs, your scatter plot and your residual plot. So I'll just go back over what I did before the bell or before the time on a free recording ran out before, is that I looked particularly at something that was a little bit obvious here with a someone who got an actual fitness test result of 30 and that their prediction was about 36, which is, it is sitting about there. And obviously the residual, or the difference between the two, is the -6 because it's going down. And we look at actual, which is this line, take away the predicted, which is this line. Okay, so the difference between, the actual, beg your pardon. Okay, the actual is our dot. Take away, which is 30, take away our prediction, which was 36, which is this line here as well. Okay, and the difference between 30, take away 36-ish, is about -6. So how that links up with your graph over here is, let's look for someone who is 175 centimeters tall. So over here, if we look at, remember the X was our height, and our horizontal line here is our X values. So this is someone here who is 175 centimeters high. Okay, and if you look here, you can see that the person that has a height of 175 centimeters has a plot on them at -6. So it's saying that this person's data, their actual take their residual, was -6. That their actual outcome was less than what was predicted for someone of their height. Okay, let's talk through another example and how you'll see the two marry up and how you can talk about it in your assignment. Let's look at someone who is 169 centimeters tall. So 169 centimeters tall, we're going to guess is this dot here. Okay, over here our residual is 3, which is perfect on this residual dot here. So this person actually jumped, remember this is the actual, this person actually jumped their actual height. It was 3 centimeters bigger, taller, longer than what is predicted for someone at their height of 169 centimeters. And over here, okay, we've got someone at 169 centimeters, and you can see that, they actually jumped 33, which is the little dot, and the prediction was 30, which is where the line, sits underneath it. So the difference between 30 and 33 is 3. Okay, let's do one more. Okay, let's look for someone who is 192 centimeters. Clearly that's this person over here. Okay, what the residual plot tells us is that they jumped 10 centimeters higher than predicted for someone for their height. Okay, so if you go back over here, okay, the 192 centimeter person jumped at about 62, and if they were only predicted to jump 52, so they jumped 10 centimeters higher. This is the 10. They jumped 10 centimeters higher than their predicted result based on their height. So it's like this is someone who is jumping even higher than they should have. This is someone jumping lower than what they should have based on their height. All right, so just so you know, grade 11s, even if in your assignment Okay, the table is easy to do. You click and drag your stuff down. Okay, there's two scatter plots and the residual plot. They are easy to do to spit out of Excel, and all this data in here is pretty easy to click and drag once you know what you're doing, right? Okay, in your assignment it will be really good to talk about just one calculation, okay, or one discussion between the two. So you could say, you know, something along the lines of the student who was 169 centimeters tall jumped 3 centimeters higher than what they should have. This is evident in the residual plot where the person's dot is sitting on 3, which is here, okay, which marries back to the scatter plot where their actual jump was sitting at 30 and their prediction was, their actual jump was 33 and their prediction was 30, hence demonstrating the 3 that sits over here on your residual, okay? So I'm sure you could probably say it a bit more concisely than that, but basically this 3 here, the 3 marries up with 33, take away 3, okay? Or this 10 that's sitting on your scatter plot, the 10 marries up with the person who was 192 centimeters tall, and the fact that they were predicted to jump only 52, but they jumped 62, representing that 10. All right, just quickly back to the slideshow. Okay, now we have to look at our scatter plot and decide whether it's still linear data, because another point of the residual plot is to determine whether the data really is linear, because the residual plot is said to be more sensitive than the scatter plot. Okay, we haven't got lots of dots here to deal with, but basically if you have a residual plot where the dots are nice and scattered above and below, okay, that 0 axis, it's said to be that your data is still linear. Whereas if you get a residual plot that looks something like this, where there's a clear system or pattern happening, it's actually classed as non-linear. But that would marry up with over here when you couldn't really say that this data was linear either, because there is a bell curve happening around that line of best fit rather than, you know, an even distribution of dots around both lines. So talk about what your residual plot looks like. Use word like randomness around the 0, or, you know, that the points are roughly spread around the 0, like this. Okay, we probably just don't have enough dots in there to show that there would have been a nice scatter. It looks a bit bellish at the moment, but it is linear data. Okay, we just only had a few dots to work with for our example. Just back to here, please use lots of textbook language. Okay, hopefully you're saying something like the residual plot appears to be random, with its collection of points spread roughly around the 0 or the x-axis line on the horizontal. Therefore, we can go with our original assumption that the data is linear. Okay, so this PowerPoint is on Teams. All of these snippings are from your textbook. Your textbook has great language that you can use for your assignment. But that's it for today. Hopefully you've seen the link. Hopefully we have done our success criteria. You can use Excel to spit out a residual plot by simply going data analysis, clicking your regression, and remember to tell that this is your Y data and, you know, your X data. It's gone from there now, but it's stuck in there. Click residuals and residual plot, and you'll get your plot, your graph to jump up at you. Okay, so hopefully you know how to compile it. The next thing is to do the calculations. So your actuals, okay, I don't know where my okay, actuals have gone there. Okay, now your predicted have to come from y equals Okay, remember your predicted came from y equals a plus bx. So we went to our line of regression over here, and our a has come from here and gone into this column all the way through. Okay, our b, which is our gradient, doesn't really matter for now, has come from here and has been stuck straight into here. And our x's, okay, our x's came, now I don't know where mine have gone, sorry, but our x's came from there. You have to multiply your b and your x, so your b and your x get multiplied to get that. And then here, your predicted is y equals a plus bx, so it's your a plus your bx. Okay, and then you drag that down, and then your residual is your actual take away your predicted. Residual is your actual take away your predicted. So there you go, actual take away that, so to get your -6. Okay, and then it's about looking and being able to identify just a couple of plots across the two graphs and seeing the relationship between these two plots. Bye for now.